61, I think again you'll find the math relatively straightforward here. The hardest part of this kind of a problem is just understanding the setup. So let's build, we have a ground here, plane is flying over the control tower, we look down at an angle of depression. So we have a control tower here, draw it like this, that's the airport, and we have a plane up here flying by, and we know that the plane is 2,000 feet above the ground, right, and it's flying right over the control tower. Over here we have Mom on the ground waving, and we're looking down at an angle of depression of 27. Important here to remember that the angle of depression is measured against horizontal, so this is what's 27 degrees. We're looking down. Don't, even though I drew that part of this part of the triangle first, you've got to remember that that's 27 degrees. We're trying to find this distance here. How far she's standing away from the control tower. And actually, I'm gonna redraw this here. I'm gonna put the control tower here just because I messed up my drawing. So that's the control tower is actually right here now. And again, so we have 2,000 feet here. Different ways you can do this. We can use alternate interior angles because the sky horizon's parallel to the ground. We know that this is 27 degrees. You could also know that this is a total right angle here, so you could deduce that this angle here is 90 minus 27, which would give you an angle of 63 degrees. Either one, this will allow us to solve for D here. I'm going to go ahead and use this angle. And from the vantage point of this angle, we're looking for adjacent, and we have opposite. So O and A suggest we want to use tangent. Tangent of 27 degrees, which is that angle there, is going to be opposite over adjacent. That's D, the unknown, over 2,000. And then to solve this, we're going to multiply both sides by 2,000. Those 2,000s will cancel, so we have this D here equals 2,000 times the tangent of 27 degrees. If you punch that in your calculator. Okay, so I punched that in my calculator, got a number that was clearly unreasonable. It was a huge number, and now hopefully you saw earlier, you saw before I did what I even did wrong here. So I'm going to go ahead and erase this step right here. Erase. I'm going to erase. And what I did wrong here is opposite over adjacent is correct, but I transposed those. I did adjacent over opposite. So actually, from 27 degrees, opposite is 2,000 over adjacent, which is D. So to solve this then, erase this here, I'm going to multiply both sides by D to get D times tangent of 27 degrees equals 2,000. D is going to be 2,000 divided by tangent of 27 degrees, and when you put that into your calculator, you will get 3,925 feet. So that's how far Mom is from the control tower. So here we have the Leaning Tower of Pisa. We see that the side of the tower is 179 feet, and if we drop something straight down off the top, it drops 17 feet away from the base of the tower. So the first thing we're trying to do is find the angle X here. Angle X, if we look at the vantage point of angle X, it's a right triangle problem. We know that we have the adjacent and we have hypotenuse. So if we think about SOHCAHTOA, we have adjacent hypotenuse. Cosine is what we want to use here. Cosine is an unknown angle, or the X is an unknown angle here right now. So we have cosine of X equals adjacent over hypotenuse. So 17 over 179. And to solve for X, we take the inverse cosine. So I'm just taking what's here and putting it inside for the inverse. And then we'll just do that on the calculator. to get a rounded value of 84.6 degrees, which seems reasonable, right? This should almost be a right angle. There's no way this tower would be standing if the angle was much smaller than that. So that's part A. Part B is how far did the object fall? So we're just trying to find the other leg of this triangle. Different ways you could do that. You could use trig ratios. I always like to use Pythagorean theorem when I have two pieces. So we call that h. Leg 1 squared is h squared plus 17 squared equals 179 squared. H squared equals 179 squared minus 17 squared. 31,752 is h squared. So h is just going to be the square root of 31,752, which if you put in your calculator gives you a distance of approximately 178.2 feet. Notice how much it's almost the same as the height of the tower. It's only 0.8 feet. So even though there's this big angle, you have a leg that's almost the same length as the hypotenuse, which happens with very skinny right triangles. So 63, we have sections of pipe are connected as shown. What is the exact length and feet of essentially point A to point B? We see a 45 degree in there. Okay, sorry about that. My OneNote rebooted on me. So we have sections of pipe here. We're trying to find A to B. We see a 45 degree angle in there. That's probably some hint that we're going to be using 45, 45, 90 triangle relationships. And so always a good strategy is to try and make squares, rectangles, and triangles in these problems, and good things happen. So that's what I'm going to do here is I'm going to make a rectangle across the top here. And when we do that, we know that this segment here is also 1 foot, which leaves 2 feet remaining for this top part. Once we do that, we can use 45, 45, 90 relationships because we have a 45, 45, 90 triangle here. So we know that, I don't think we need it in this problem, but we know that this leg is also 2 because this is isosceles. And then the hypotenuse is always the side times root 2 for a 45, 45, 90. So this is going to be 2 root 2. And that's the answer for this one, 2 root 2. I'm not going to do this one in its entirety. First of all, my diagram's a little bit messed up here. But these are, we like to call these angle and side chasing problems, and you're just trying to find how to think about this by tracing through the diagram. So usually you have to find a good starting point. If we scan through this, first of all, I like to look at the 45, 45, 90 triangles here. So it's pretty clear that this is 45, 45, 90, so we know Q is going to be 13 just because these sides are the same here. And then the side of a 45, or the hypotenuse of a 45, 45, 90 is always the side root 2. So R is going to be 13 root 2. So that's 2 of them. We found Q, we found R. T and S can't really work on here. U, we could do that with using right triangle trig on this triangle here. I'm just going to set up the ratio. You can solve it. But if we look at this angle here, we have adjacent and we have opposite. So that sounds like tangent. I'm sorry, we have hypotenuse. We have opposite and hypotenuse, which is SOHCAHTOA. So sine of 43 degrees is going to be opposite over U. So you can solve that to get U. If we look over here, P you can get by Pythagorean theorem because we have a 30, a 34. That's actually a multiple. It's an 8, 15, 17 multiple. 8, 15, 17 is a right triangle. So if I multiply those by 2, you get 16, 30, and 34. So I can tell that P is going to be 16. T, we can use another multiple here. This is going to be a 3, 4, 5 multiple. So T is going to be 12. And this way to see that is 3, 4, 5 is, if I multiply that by 4, 3 times 4 is 12, 4 times 4 is 16, 5 times 4 is 20. So 12, 16, 20 is a Pythagorean triple. So 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. 12, 16, 20. And then S is going to be 5 for the same reason. 5, 12, 13 is another Pythagorean triple. But you can use Pythagorean theorem for all those. You don't have to memorize these triples. And then the last one here is up in the left corner. We see that the side opposite of 30 degrees is 30. The hypotenuse is always double, so M is going to be 60. And then the other leg is always the shorter side times square root of 3. N is going to be 30 root 3. So hopefully that gives you enough to go on for that particular problem.